Today, we will be discussing a very important chapter, Language of Chemistry. In this chapter, we will be discussing about chemical reactions. So, what is a chemical reaction? We have already studied chemical change. In a chemical change, a new substance is formed. So, a chemical change is also known as a chemical reaction. A chemical reaction is a chemical change in which two or more substances react to form one or more new products. A chemical reaction is denoted by writing a chemical equation by using symbols and formulas. We have already discussed how to represent elements using symbols and how to write chemical formulas. See the equation I have given in the screen. A plus B gives out C plus D. This denotes a chemical reaction where A plus B are the reactants and C plus D are the products. Today, in this chapter, we will be discussing about the characteristics of a chemical reaction and the various conditions necessary for a chemical reaction to take place. A chemical reaction can show various characteristics. A gas may be produced, there may be a change in color, heat may be absorbed or produced, a precipitate may be formed, there may be a change in state, that means solid, liquid, and gas. And sometimes there may be a generation of smell. So let's discuss about the characteristics of a chemical reaction in detail. The first characteristic is evolution of a gas. Some chemical reactions are characterized by the evolution of a gas. If this reaction is carried out in a liquid medium, the gas produced or evolved can be seen as bubbles in the liquid. This is known as effervescence. The evolution of a gas is represented by an upward arrow. Let's see some examples. When zinc is reacted with dilute sulfuric acid, hydrogen gas is evolved with effervescence. See the figure that is given on the screen as well as the equation. Zn stands for zinc, H2SO4 is sulfuric acid, and in front of sulfuric acid we have written DIL, which stands for dilute, gives out zinc sulfate, and H2, upward arrow indicating gas. The next example is reaction between sodium bicarbonate and acetic acid. When sodium bicarbonate and acetic acid reacts, an effervescence of a gas is produced. The gas produced is carbon dioxide. You can try this simple experiment at home. Sodium bicarbonate is nothing but baking soda, and acetic acid is vinegar. So take a small amount of baking powder and to it add vinegar. You will see effervescence being produced. The effervescence that is being produced is of carbon dioxide. See the reaction. NaHCO3 stands for sodium bicarbonate. CH3COOH stands for acetic acid, produces sodium acetate, water, and carbon dioxide. Next to carbon dioxide, you will see an upward arrow which indicates production of a gas. The next characteristic is change in color. Let's see some examples of a chemical reaction where there is change in color. Copper carbonate is pale green in color. When it is heated, it produces copper oxide and carbon dioxide. The copper oxide is black, so there was a change in color. It was pale green, the reactant was pale green. When it was heated, the product is black. So here we observe a change in color. See the chemical equation: copper carbonate within brackets pale green and copper oxide within brackets black. In this equation, it is very necessary to mention the change in color. Let's see another example. When copper sulfate reacts with hydrogen sulfide, copper sulfide and sulfuric acid is produced. The copper sulfate is blue in color, whereas the product copper sulfide is black in color. So there is a distinct color change from blue to black. You can see it in the figure. Now see the equation. In the equation also it is necessary to mention the change in color. So below copper sulfate you have to write blue, and below copper sulfide you have to write black. It is very necessary to mention the change in color. Now next to copper sulfide you will see a downward arrow. I will be explaining later what does the downward arrow indicate. The next characteristic is evolution or absorption of energy. Depending on the evolution or absorption of energy, reaction may be of two types: exothermic reaction and endothermic reaction. A reaction in which heat is produced or evolved is known as an exothermic reaction. Let's discuss about some examples of exothermic reaction. The first example is reaction between magnesium and dilute hydrochloric acid. When magnesium reacts with dilute hydrochloric acid, magnesium chloride, hydrogen, and heat, a large amount of heat is produced. See the equation: magnesium Mg plus HCl gives out MgCl2 plus H2 plus heat. So heat is being evolved, so it is an exothermic reaction. Instead of writing heat, you can also use a delta sign. A delta sign indicates heat. The next reaction is between calcium oxide and water. When calcium oxide reacts with water, it produces calcium hydroxide along with a large amount of heat. Hence, it is an exothermic reaction. You can easily try this at home, but you have to take a very small amount of calcium oxide. Now you may be thinking, where will I get calcium oxide from? You know what is tuna? The one that we use for whitewashing. So if we take, and that is nothing but calcium oxide. So take a very small amount of tuna or calcium oxide and add some amount of water in it. You will see that huge amount of heat is produced. When you even hold the container, it becomes very hot, indicating a large amount of heat is being produced. So it is an exothermic reaction. A reaction in which heat is absorbed is known as an endothermic reaction. Let's discuss some examples of endothermic reaction. The first example is the reaction between nitrogen and oxygen. See the chemical equation: nitrogen and oxygen at a temperature of 3000 degrees Celsius produces nitrogen monoxide. See the amount of heat that is being absorbed: 3000 degrees Celsius. So since heat is being absorbed, it is an endothermic reaction. Next example is decomposition of calcium carbonate. When calcium carbonate is heated to a temperature of 1000 degrees Celsius, it breaks down to produce calcium oxide and carbon dioxide. See the chemical equation. Above the arrow you will see 1000 degrees Celsius. That means The temperature that is being maintained is 1000 degrees Celsius. That means heat is being absorbed here up to a temperature of 1000 degrees Celsius. So this is an example of an endothermic reaction. The next characteristic is formation of a precipitate. What is a precipitate? Sometimes when two solutions react, they form or they produce an insoluble solid. This insoluble solid is known as a precipitate and it is denoted by a downward arrow. Remember, we had done one equation before where there was a downward arrow in characterized by color change. So that is also a precipitate. So downward arrow indicates formation of a precipitate. So let's discuss some examples of chemical reactions where precipitate is formed. The first example is reaction of silver nitrate and sodium chloride. When silver nitrate and sodium chloride react, they produce a white precipitate of silver chloride. You can see it in the figure. See the equation. Next to silver chloride, I have written downward arrow which indicates a precipitate, and below AgCl I have also mentioned white. That means you have to mention the color of the precipitate also. The next example is reaction between iron sulfate and sodium hydroxide. When iron sulfate reacts with sodium hydroxide, it produces a green precipitate of iron hydroxide. See the figure. You will see a green precipitate being formed. See the equation. Iron oxide, downward arrow indicating it is a precipitate, and the color has also been mentioned, green. So always remember, precipitate is to be denoted by a downward arrow and you have to mention the color. And a precipitate is formed when two solutions react to form an insoluble solid. Sometimes a chemical reaction is characterized by the change in physical state. That means a solid may change into a gas, or a gas may change into a solid, a liquid may change into a solid, a liquid may change into a gas. So let's see an example of a reaction where there is change in physical state. The example to show the change of physical state is when ammonia gas reacts with hydrogen chloride gas. So remember, ammonia is also gas, hydrogen chloride is also gas. They produce a white solid known as ammonium chloride. See, two gases are reacting to give you a solid. So there is change of physical state. See the equation. NH3 within brackets G is written where G stands for gas. You can use an upward arrow instead of writing G, plus HCl, that is hydrogen chloride gas. Instead of again G, you can write upward arrow, gives out NH4Cl, that is ammonium chloride, and within brackets S, which indicates solid. So you have to mention that within brackets you have to write S. So don't forget to mention the gas, and solid to show the change of physical state. Some chemical change may be characterized by generation of smell. So when a chemical reaction occurs, sometimes very characteristic smell is produced by which you can identify what or which gas is being produced. So one of the characteristics of a chemical reaction is sometimes there is generation of smell. So let's see an example for this type of chemical reaction. When hydrogen is passed through molten sulfur, it produces hydrogen sulfide. Now, when hydrogen sulfide is being produced, it has a very characteristic smell of rotten eggs. So the entire laboratory is filled with the smell of rotten eggs, and you come to know that is hydrogen sulfide. So in this case there is generation of smell. So this reaction is an example of generation of smell during a chemical reaction. So, the different characteristics of a chemical reaction are: in a chemical reaction, there may be an evolution of a gas, there may be a change in color, there may be absorption or production of heat energy, there may be a formation of a precipitate, there may be a change of physical state, and there may be generation of smell. Now we will be discussing about the conditions necessary for a chemical reaction to take place. The various conditions necessary for a chemical reaction to take place are: number one, close contact. Some chemical reactions take place when reactants come in close contact. That means you don't have to do anything. If you just keep it in close contact, also they react. So let's see an example of such a reaction. When sodium comes in contact with water, it acts vigorously. In fact, an explosion takes place. So, if you just take a piece of sodium and keep it on the table, it will react with the water vapor that is present around it also. So, as soon as it comes in contact with water, it reacts, and the reaction is explosive. See the equation. Sodium reacts with water to produce sodium hydroxide and hydrogen. The explosion is due to hydrogen gas that is being produced because hydrogen burns in air. The next condition is some chemical reactions occur only when the reactants are in the solution form. So let's see an example of a chemical reaction in which this condition is required. If you remember, we have already done this equation, the one in which a precipitate is formed. So I told you sometimes two solutions react to give an insoluble solid to form a precipitate. So what was the condition for the reaction to take place? We were taking two solutions. That means the reactants should be in the solution state. Here, silver nitrate and sodium chloride both in their solution state. See in the equation, AgNO3 within brackets AQ is written and NaCl within brackets AQ is written. AQ stands for aqueous, which means solution in water. Aqueous means which is mixed in water, aqueous solution. The next condition is some chemical reactions occur only when the reactants are heated. So let's see an example of a reaction in which this condition is required. We have already done this reaction. When calcium carbonate is heated to a temperature of 1000 degrees Celsius, it decomposes to give calcium oxide and carbon dioxide. So without heating calcium carbonate, this reaction does not take place. So your heat is one very important condition. See above the arrow. Look at the temperature that has been mentioned, 1000 degrees Celsius. So that is the condition required. The next condition is light. Some chemical reactions occur only in the presence of light. Such a reaction is known as a photochemical reaction. Photo meaning light. So, a chemical reaction which occurs only in the presence of light is known as a photochemical reaction. We have studied one photochemical reaction in biology, if you remember, photosynthesis. It occurs only in the presence of light. Let's see another example of a photochemical reaction. An example of a photochemical reaction is when silver chloride is kept in sunlight, it decomposes to give silver and a greenish yellow gas known as chlorine. Look at the equation. Above the arrow, I have mentioned the condition, that is light. So light is a condition necessary for this reaction, and it is known as a photochemical reaction. The next condition is electricity. Some reactions occur only when electricity is passed through it. Such a reaction is known as an electrochemical reaction. A reaction in which electricity is required is known as an electrochemical reaction. Let's see an example of an electrochemical reaction. An example of an electrochemical reaction is passing electric current through acidified water. What do you mean by acidified water? Water which contains some amount of acid is known as acidified water. So when electric current is passed through this acidified water, it decomposes to give hydrogen and oxygen. So here the condition required is electricity. So see above the arrow we have written electric current, which is the condition required for this reaction to take place. The next condition is pressure. Some chemical reactions occur only when they are subjected to high pressure. So let's see an example of a chemical reaction where pressure is applied. Nitrogen reacts with hydrogen only when it is subjected to an extreme high pressure of 200 atmospheres to produce ammonia. So see above the arrow, the condition required is 200 atmospheres. If this pressure is not maintained, then the reaction will not take place. So the condition required here is pressure. The next condition that is required is a catalyst. So what is a catalyst? A catalyst is a chemical substance which speeds up the reaction without itself undergoing any change. What does this mean? This means that a catalyst will only increase the speed of the reaction, but itself will not take place in the reaction. Its work will only be to speed up the reaction, but will not take part in the reaction. Let's see an example of a chemical reaction where a catalyst is required. Potassium chlorate, it decomposes to give potassium chloride and oxygen. But in this case, if a catalyst manganese dioxide MnO2 is added, then the reaction will be faster. See the equation, MnO2 has not formed anything. That means it has not taken part in the reaction. But what is its role? It is only increasing the speed of the reaction. So it is a catalyst, and since it is not taking part in the reaction, we write the catalyst above the arrow. So catalyst is another condition required for some chemical reactions to take place. Today, we discussed about the various characteristics of chemical reactions and the conditions necessary for a chemical reaction to take place. Thank you. Bye-bye.